Morning, guys. So I did have a student ask me about extra practice for graphing polynomial functions, and don't really seem to have a lot of worksheets on that at my hands. So I thought it's actually pretty easy for you to create your own equation and then test it using Desmos to do that. So I want to give you an example of this. Okay, so I'm going to share my screen with my OneNote, and what you'll see here is we just create our own polynomial function, and I'm going to write it in factored form. My pen is not, what is working good? Let's say no to that. Okay, so what I probably would do is get my pen working first, is just write a function. I don't know, maybe let's put a bracket and x plus 2, and then we could square it, and then I don't know, x minus 4, you cube it. And we could write anything we want. Most likely on the test, I'm not going to be having a graph like something like x to the 13th or something like that. So it's going to be a reasonably small degree, probably less than 7, I would think. So if we did this, and maybe we could put a negative in front of all that just to see what would work here. So when we go through all this, we kind of look for like our x-intercepts first. So we should have one at negative 2, 0. And we should have one at 4, 0. And we notice that the one at negative 2, 0 has a multiplicity of 2. So it's an even multiplicity, which tells us it should kind of bounce back the way it came in from. So if it's coming in from underneath, it should bounce back down. And if it's coming in from above, it should bounce back up again. And in this 4 is a multiplicity of 3. So that's important. We also know the degree of the polynomial is x squared times x cubed. So it would actually wind up being x to the 5th power. But we notice the negative in front of all of it, which would give it a negative x to the 5th is our leading term here. And that's an odd degree, so it's either going to be down, up, or up, down. Because it's negative, it should actually be up, down. Okay. Now there's other ways we could test this, but I think that's enough information to get the basic shape here. So I could plot my x-intercepts first. So we said one at 2, or sorry, one at 4, and one at negative 2. And now the y-intercept of this graph is going to be fairly large as far as a number goes. It could be negative or positive. We'll have to work it out. But we've got negative 4 being raised to the 3rd power, and we've got 2 being raised to the 2nd power. So I could write this as p of 0 should equal negative, and then it'd be like negative, or it'd be positive 2 squared times negative 4 cubed. Okay. So we've got a negative cube, so that's a negative times a negative is a positive. So we really should have 2 squared, which is 4, of course. See, I'm pretty good at math. And times 4 raised to the 3rd power. So it's 256. So we're not going to do a whole bunch of dashes up there, but I'll just kind of go 256. Okay, put a point here. And we said our end behavior was up, down, with a multiplicity of 2 at negative 2. So it's going to be kind of going upwards and then kicking up. Now, it may turn out that that y-intercept, I mean, it could be the highest point, but I'm thinking not, but maybe somewhere down. Now, when it goes to 4, notice that it's got a multiplicity of 3 there. So I can't just show it going through like that. So I need to clean that part of the graph up a bit. And just, oh man. Error. So I'm not sure what's happening here. There we go, let's get rid of that. Okay, so we're gonna have our graph come down. It does go through, of course, it's odd. And it comes in, kind of looks like it's going to turn, but actually goes back down again. So this graph actually has only 2 turning points. Not that we really asked that, but there's a turning point at the bottom and a turning point up here. Now, probably on the test, these numbers would be much easier for you to work with, but we would like you to find out what we call a relative maximum. So write a coordinate up here for what that point is, and you would want to plug a number in, like maybe 1, and see what your y value is there. Okay, so what I was thinking was if you want to do more practice like this, you could just create your own function. And once again, you could put it just an x in front this time, like no binomial here. So just x, and then put a couple brackets in. Put a couple brackets in, and you make your own equation. Maybe you raise this one to the 2nd power, this one to the 3rd power. And now, of course, the big question is, well, how would you even know if you're right? Like, how do you know you're correct here? Okay, so I'm just going to make a note of the equation I wrote above, which was negative x plus 2 squared x minus 4 to the 3rd power. So now what I would do is I would stop sharing that screen, and then we'll share. Where's Desmos? There we go. So now here, when I'm in Desmos, what I can do is I can just type in the equation here. And so I go y equals, not double equals, y equals, and now I need to have these in brackets. So I go negative x plus 2, close bracket. And now to raise it to a power, I have to get this little symbol. It's actually above the number 6. It looks kind of like a little sort of a top of a mountain kind of thing. So above number 6 on your keyboard should be a little hat thing there. And I'll write it out on the OneNote again, just so you can see it. But then I would enter 2, and then I need to use the arrow key to get out of the exponent area, and then another bracket, and then x minus 4, close bracket. Now, of course, this is to the 1st power. So what I want to do is raise this to 3rd power. Now, of course, my graph is huge looking, because remember, we went all the way to 256. So you can obviously adjust your margins and stuff like that. So one way to do that, of course, is to go into this little setting here, and you can change your, let's keep the x not too ridiculous. Let's go from negative, not that bad. Let's go negative 5 to 5. And then our y values, we're gonna have to make them quite large actually. So let's go negative 100 maybe, to, let's go 300. And once again, you could adjust this for your own visual pleasure. Let's close that down. And once again, you can see maybe you want to expand it over here to see more of the graph, see what it kind of looks like. And then you can add other functions on here, but they may not all scale the same way. So if I go y equals x, and then maybe bracket x plus, say 5, close bracket, and then bracket x minus, let's say 3, let's go minus 2. Then I can raise this to, oopsie, go back one there, close the bracket, and raise that to, let's say, the 5th power. Okay, so here you've got 2 x-intercepts. Actually, sorry, you should have 3 x-intercepts. Oh yeah, you can barely see it over here. Maybe I'll change that so I can see it. Let's go plus 3. There we go. But you can see this blue graph even goes higher than the red graph does. So you might need to adjust your scale a little bit on your settings. But if you use relatively small numbers, like the powers aren't so big, I'm thinking you're going to see a more reasonable graph here. So there, yeah. So that's a bit more shallow. If a graph can be shallow, and yeah, so you can change it up a little bit and do what you want. So you can enter any equation you want in. Keep in mind that I'm going to probably be keeping this to a reasonable degree here. So probably once again below 7. So whoopsie, I shared the wrong screen. Let me try that one more time. I'm just going to sign off here. So there we go. So let's just share this one more time. So we were talking about how to get the power here, so how to show that power. And so if you look at, usually, at least on my keyboard, have two keyboards here because that's just the kind of guy I am. So if I look at number 6, above the number 6 key on the keyboard, you'll see this little symbol. Looks like that. And so what I would type in is something like y equals x plus 2. And then I use that symbol and 3. So that actually would translate into y equals x plus 2 to the power of 3. So that'd be a third degree polynomial. Okay, so I'm going to sign off here. Once again, this is just if you want extra practice on graphing, and then how would you know if you're right? Just use Desmos here. Okay, so I'm going to stop sharing and hope that helps you. And take